I guess if you're MSNBC, it is. CNN. And armed, including, for instance, Antifa medic, the one that aimed...
Hello, and welcome. The General Electric is pretty much finished, at least as far as I'm going to take it. It cleaned up pretty well. If you take a look at this compared to what it looked like when I first dropped it on the table. And I think I'm going to leave this alone. It looks more like a scratch than a crack. I fiberglassed inside and it's perfectly solid. The crack on this end was right in this corner, and I put a fillet in behind there of JB Weld. I couldn't do anything else because the chassis comes so close to the edge. There's a little chip here. I could probably get some resin, try to mix a color in to match and buff it up. But I'm just afraid I'd end up doing more damage. The shiny surface on this stuff is fairly thin. I think it's good enough compared to what it looked like. So this radio is finished, other than I'm still working on the insert for the dial. It's very time consuming. I have played with the exposure in my Photoshop program, and now I'm filling in all the details on the numbers so that I can print it out on some heavy photo paper and slip it up in there, and that'll be nice and clean and new looking. So we're going to get this one off the bench, and today the travel air showed up. As soon as I get the cord untangled from everything on the table here, we'll set this aside back here on the shelf, and we'll bring the next victim up to the surface. It isn't all bad news. The little plastic insert's missing, but the needle, the pointer, is intact. I can get a replacement window for this for about $20. There's a guy that sells replacements for these radios. There's a little bit of damage over here on the dial face, but I haven't found a replacement for this style. They do have a Traveler, but it's not this model. This, I believe, was originally the ivory model, and somebody tried to stain over it or paint over it and make it look like wood grain. That, of course, all has to come off. The good news is there's no cracks anywhere on this cabinet. And another silver lining, I hope, in the clouds. It appears to be it's mahogany underneath the ivory paint. I went online and researched solvents to safely remove the paint from Bakelite, and they say as long as you use a non-caustic solvent-based paint remover, you'll be safe. Bakelite is pretty much impervious to solvents, but anything caustic, including like 409, will just take the finish right off. It'll take the shine off and you'll never get it back. The paint does chip off. If you take something, you can chip the paint off. But I've also read online that the ivory units were the mahogany rejects. And the factory, in order to save the cabinets, painted them ivory and gave the customer the option of the mahogany or the ivory. You know, it's a good way to save the units. You're not throwing them out, paint them ivory, and if people prefer that, great. I prefer the mahogany myself. So we're going to make an attempt at some point to strip this. I've already done a couple of test spots here on the bottom. I used acetone and lacquer thinner. The lacquer thinner appeared to be starting to soften it. I'll do some tests on the bottom with 2 or 3 paint strippers before I do the top part of the cabinet. Having said that, I had thought the back with the antenna was broken, but it turns out that's fully intact. there's a second back. There were some pieces under these little holders here. There's a second back that goes on this radio behind the antenna that just about completely covers it up. Goes under these 4 snaps. Well, there's 3. One's missing. But even these bosses are intact. And there's a guy online who sells reproduction backs. They're not cheap. They're like $22. So between the plastic in the front and the back, there's another $40 and a radio that I already paid way too much money for. It's a good thing we love this hobby. The cord is nice and stiff. Wow. I'm not even going to try to yank that out. I'll pull it all out with the radio. We're going to try to make this a teaching set. I'm going to try to explain some of the circuitry as we troubleshoot, so those out there who are just getting into this might feel a little bit braver about digging into one of these and understanding some of the problems they might have. But right now I'm going to pull this out of the cabinet and we'll take a look inside. I won't bore you with that part. Okay, at some point somebody has been in here. The 2 screws that go over here on the sides that hold the chassis in the cabinet were not screwed all the way down. Fortunately, however, the bosses are intact, as are the threads. These are machine screw threads, and they're fully intact. Neither one of them is stripped out, which is a big plus. The General Electric set had 2 bosses similar to this up on the top for holding the top of the antenna and back in place, and one of them had been ripped out. Half of its length was missing. So what I did is I took a couple of pieces of Lexan and I made like a little form in here and filled the whole thing with JB weld. And when that was set up, I drilled it and tapped it, and I did the same on the one that was still existing. I tapped them about 1.5 inches deep as I could get the tap in. And then I used a long threaded screw so that it had plenty of thread to hold it in. Came out pretty good. I was real happy with the results. This is just going to need a good cleaning. The grill cloth is in there, but I think that's beyond saving. We'll have to find a replacement, suitable replacement for that. There's a lot of places online that sell grill cloth, so we'll find something to stick in there. For the radio itself, this is what we have so far. This is the cord. I didn't want to try to pull it out. I didn't want to endanger that. This appears to be the external antenna wire, which is way past its sell-by date. In fact, where's my nippers? I'm just going to remove that right now before it leaves cracked and broken insulation pieces all over the bench. That's gone. We'll be replacing that. Alright, what's the good or bad news? The good news is I believe this set is untouched as well. I don't think anybody's done anything to this. That appears to be the original electrolytic, and all of the paper capacitors appear to be original. I don't see any new resistors. I see nothing. Okay. Let's see if we have any continuity through the filament string here. Get the VOM over here. Just curious to see. The speaker doesn't rub, that's a good one. As long as I don't jinx that and end up sticking a finger through it. We'll probably cut a piece of cardboard. I didn't do it on the other one, but it's a good idea to cut a piece of cardboard and just stick it on the front. Ooh, that's stiff. But it turns. Are we in frame here? Yes, we are. Let's Go down here, R times 10, and we got nothing. Not surprising. Not surprising. Oh, before we go too much further, Bob Gibbons, or Robert Gibbons, hello Robert, sent along some information about where he thought I could find some of these inrush current limiters to preserve the tubes, and I contacted several manufacturers. Now they have listed here what is just about the ideal unit. We have a 20 ohm and a 60 ohm. The 40 or 60 watt light bulb rather that I'm using for a dim bulb is 60 ohms when it's cold, and so it goes from 60 ohms to 1.8 ohms when it's fully warmed up, which wouldn't be much of a voltage drop, and it's rated for 300 milliamperes, which is perfect. The General Electric pulls about 260 when it's running, so 300 milliamp unit would be absolutely wonderful. That was Cantherm. Little Fuse had one listed that's 20 ohms cold and 1 ohm warm, and it is also 300 milliamperes. The bad news is nobody has these anymore. In fact, Little Fuse had an explanation on their website, and they said due to a total lack of sales over 4 years for these things, they've been discontinued. And I put in an RFQ, request for quotation, to a couple other places. They all say out of stock, unavailable when they come back to me. The thing is, they are only, does this have the price? It doesn't even have the price listed. Oh yes it does, 36 cents on this one, 29 cents on that one, 57 cents on this one. The Little Fuse doesn't have a price listing on it. I would happily pay 10 times that, $3.60 for one of these to save the radio. I would think that's a deal. So there's a business opportunity out there for somebody. If they're this cheap to make, they have to be relatively easy, to add to their production run. It's just they don't stock them anymore because they haven't been selling. But if somebody out there wanted to invest a little cash and buy, say, 5,000 units or 10,000 units, and at that price it wouldn't be an awful lot of money, and then you could turn around and sell them for $1 or $2 and probably make a tidy little sum selling these. I'd be willing to help you out with a video explaining what they were to put on, whatever sales website you stick them on, whether it's eBay or whatever. I really don't want to get involved in the sales end of it. I got so many other things going on, but if somebody out there is ambitious and bought these up in bulk, you could probably convince one of these manufacturers to make a run of these, and it would be a big boon to the antique radio community to have these available. So anyway, we tried, we can't get them unless somebody knows of another source somewhere. Aha! The dial string broke. When I got this ooh, the tuning condenser is some kind of stiff. When the radio first got here, I turned the knob a couple of times and the dial did move, and then it quit. And sure enough, the dial string is rotted away. So we'll take care of that. The knobs are missing. I think I can pick up some knobs from one of the sites I found today that will be a close match. Oh, there is a rip in the speaker right there. Just a small one and a tiny one there. Nothing serious. The cone isn't rubbing. So we'll clean that up. I'm going to get some of the dirt off of this thing and then we'll start troubleshooting. Okay, I've dropped the back down so I could get in here to clean more readily. While this is forefront in my mind, I want to mention this capacitor here that's on the antenna loop. On the sets that have an external antenna connection, as this one does, You can use either the loop antenna or connect an external antenna for much stronger reception. That capacitor should be one of the Y rated capacitors. In other words, AC to ground. That capacitor is right here on this part of the antenna circuit. And I've color coded this so we can, later on, it'll be easier to follow for the guys who are just getting started here. This here is the antenna circuit that comes right down to the B minus line. Okay? Depending on how your house is wired, even if you have a polarized plug, this could end up being live AC. It's connected right over here. Now, this set has the switch connected to the B minus. I am going to change that. The trouble with this setup is when you open this switch, you still have an AC path through the filament string to the B minus line, and 150 milliamps, which is what these tubes pass, is enough to kill you. So I am going to set it up so that this is on the neutral leg, and hopefully your house is wired correctly. And I'm going to put the switch in the hot lead so that when that switch is open, this radio is completely dead. There's nothing that's going to get you. However, this is the B minus line, and it is directly connected to that external antenna. This green line is the loop that goes around the main loop and out to that external antenna. So that you want a safety capacitor there as well as here, and an across the line safety capacitor here. So you're going to have an X, a Y, and a Y. It's fairly important that that capacitor is, this antenna is made safe. Back in the day, if that cap was bad and you walked outside on a damp day to string the antenna outside in your bare feet, as you'd be wont to do on the farm, you'd be in for a bad day. So we're going to move on here and do some cleaning. Through the magic of YouTube, it's about 3 days later. I've been busier than a one-arm wallpaper hanger. There was a antique radio flea market today in Nashua, New Hampshire, and I found a pair of knobs that are nearly identical to the ones that belong on this set. The knobs were missing. This has the right fluting on the edge and the right raised center. The only difference is these have little pointers on them, and the original ones didn't, but that's fine. They fit the shafts, they turn everything. We've restrung the dial cord, we've got some protection over the speaker, and I've done some reinforcement on the back here so it doesn't get broken while we're moving the radio around. The really cool news is, while I was there today, we scored a couple more projects. So we have some future stuff to do. We have on the top here a triad, which I've never seen before. I've never seen that brand, and evidently it's exceedingly rare. I can't find any information online. And this is actually an All-American 6. It's got an RF amplifier in the front of it. But I'm not worried about not having the schematics, because we're going to, this is going to be a good teaching moment. We're going to show you how to make your way through one of these using somebody else's schematics and a tube manual. These radios are so similar that it should be no problem at all for us to pick up the tube manual, check the pin out on the tubes used in this set, and find our important test points down through the radio. It's not going to be a big deal. These radios are very basic, and we should have no problem whatsoever. It does need a lot of cabinet work, a lot of the veneers peeling off of it. And this front appears to be cardboard with a veneer on it. It's very soft and mushy, but we're going to see what we can do to clean this set up and save it. I found one other triad radio online. It was one for sale on eBay. Instead of having 4 slots like this, it had 6. and it had 3 knobs across the front. This one has 2 knobs and 4 slots in the front of it. But antique, what is it, radiomuseum.org doesn't seem to have any listing for Triad. When you search for Triad, you come up with some radio station, I think it was in Chicago, for some period of time, where you come up with Triad transformers. No model number, no information, but the radio appears to be mostly complete. Oh, there goes some of the veneer. It's got the loop antenna, all the tubes are in it. I don't think we're going to have any problem with this set whatsoever. The top's got a bow in it, and what I usually do with that is I'll put a block across the top. Are we still in frame? Yeah, I'll put something, I've got a metal bar I'll put across the top and shim up, and then wet everything down and clamp it so that it's pulled slightly upwards. You let it sit there for a couple of days and then take the clamps off, and it usually straightens the top right out. You don't want to bow it up too far, just enough to straighten it out. And the other set here, okay, we'll try this again. Just as I was saying, the other set here is a General Electric. The lithium-ion batteries went dead because I had the thing unplugged again so that it wouldn't be creating interference in the last piece of the video I was doing. The stupid power supply for this camera is so noisy, RF noisy, but it's plugged in now because it's not going to be a problem. This General Electric does not use a loop antenna. It appears to be all here. Looks like at some point somebody might have put a new cord on it, but this new cord, quote unquote, is pretty old. The back is here, although it's ripped in a couple places. It's mostly here. I can put something on the other side to give it some support back. I have the model number information on this. My question is, I'm not a dead tree carcass guy, and can you see the tiger stripe type of finish that's on the corner here, on the front, top and bottom, and on this side? Now, I don't know if that's a veneer or if that's printed on. It seems thicker than a paper over here where it's chipped, but I really don't know. It looks like an extremely thin veneer. So, and my damn laptop just woke up again. I keep shutting it off. Oh well, I'm not going to worry about that. The grill cloth's in good shape even. This ought to clean up nicely. That stupid thing. Yeah, it just woke up. At any rate, I'm not going to worry about the laptop. We've got, shortwave AM and what probably is a tone control on the GE here. Let's see what the schematic says. I haven't even hardly looked this thing over. Yep, tone control. One of them's a tone control and the other one's a shortwave and AM switch. The dial strings on both of these are intact, which is surprising after all that time. At any rate, we've got some projects for the winter. This unit ought to clean up, and we'll get this one going as well. So I'm going to set this back down on the floor. And before we get going here, I'm going to take this opportunity to address some viewer stuff. It seems like no matter how many times over the years I say that I'm trying to bring newbies up to speed, this is what I do most of the time, is try to help people out, so people who want to get into this hobby have some idea of what's going on. And I get lots and lots of feedback from people who are very grateful that I take a methodical approach, and yet I get emails almost every video of, if you knew what you were doing, you just go in and change all the capacitors. I'm paraphrasing there, by the way. I have done that. I often do it when I'm not doing a video. I can go in and shotgun the capacitors. However, I've been burned once. I've got a receiver that's downstairs that I went through. It's an AM FM set, early AM FM set, and I went through and changed all the capacitors, only to find out that somebody had been in there before me and some of the RF coils in the front end were missing, and he had made this kludge out of resistors and capacitors to try to get it going. The set works, but it's as deaf as a stump because the RF amplifier in the front end isn't working, and there's no information on what the coils are. You know, I can't reproduce it. The only thing I can do is someday hopefully get my hands on another set and copy what's in there. And for a newbie doing this, to get in there, and I've said this 1,000 times and I'm going to say it again, I'm going to show you what has to be changed initially to test the radio, and once you know the radio works or doesn't work, you've got a good baseline to continue. But if the new guy goes in there and shotguns everything and the radio doesn't work, he's left wondering, did it not work before or did I break it? So I am going to continue showing you how to bring it up methodically in steps so that you have a better chance at success. And I don't care if you want to shotgun your caps, you do what you want to do. I had another viewer who said, and he was nice, he said that he thought that I should be replacing every cord on these sets with one of these. And I don't know if anybody caught it the other day when I put that little white AC/DC set up here to demonstrate inrush. It had one of these plugs on it. I used to put these type of plugs on all of these sets. I no longer do, and I've got some very good reasons not to. I have had so many customer complaints. They go home and they don't have a 3-prong outlet, and they've got to come back and I've got to put a 2-prong outlet polarized plug on it, or polarized plug on the radio so it goes in their non-grounded outlet. I had one guy come in with a second set for me and he said, don't bother with this. He said, I cut these off anyway because the wall warts that I have in the wall won't allow for this extra thickness on the plug. He said, so I've been cutting the pins off and turning them over so they'll fit over the transformer for whatever he was charging. So there goes your ground reference right out the window. So having been through the, oh, and another guy, here's the worst case. One guy took a radio home, plugged it in, there was a flash and all the lights went out. And there was no way. He just accused me of, you know, destroying the radio and not knowing what I'm doing, and there was no way I could explain to him that his outlet was wired wrong, because when I said that, he told me I was full of shit because everything he plugged into that outlet worked fine except the radio. So I no longer use these plugs on these types of radios. It'd be okay if the outlet's backwards with the set like this. It only has a capacitor going to the chassis, but that little radio I had up here the other day is a true hot chassis radio, and the problem with those is they use the chassis for B- ground all through the set, and if you try to convert it over, it's hours and hours and work isolating everything, and sometimes it's, you know, it's right to at the tube socket they're grounded. 2-prong polarized plugs are what I use. People have been living with those on lamps for years. If you put it, you know, if your house is wired wrong with a lamp, you got just as big a shock hazard. When you unscrew the bulb, if the outside of it's hot, you're going to get bit if you're grounded. And one more thing. I have said at least 100 times in the last year or more that I'm using an isolation transformer. And that box has an isolation transformer. It says right on it, variable isolated AC supply. I always use an isolation transformer. I'm always preaching to use an isolation transformer, and I get an email that says, you should be using an isolation transformer. So somebody's not paying attention. Okay, I've got a question for the viewers, another question, because believe it or not, I don't know everything. Do we know what these are called? The real name of these things. These are the little push-in, I don't know what to call them, push-in rivets, push-in buttons that hold the back, the second back, on the rear of this radio. There's one missing. I don't know what to call them to search for them, or even if anyone ever has them. Alright, moving on. We'll get back to fixing this radio here. It's up on the bench. I am going to check our filament string because that hasn't been done yet. All I've done to this is some mechanical stuff. I covered, the speaker. I fixed the dial cord. I put some little pieces here to keep from breaking off the ears. This is basically cardboard. So when I tip the radio back and when I lay it down on its back, I put a piece of foam in here for support just so that, oh, and I glued the antenna on. It had masking tape all over it, so we took some hot melt glue and fixed the loop antenna. That's all that's been done to this at this point, because I want you to experience it with me as we do it. Ah, so nice to have a good looking pair of knobs on there. No, don't go there. Alright, I'm going to hook up my ohm meter. I'm going to set the thing down here on, I'll go to 1K, or times 1K. And zero up the meter. Not that that's important, but there we go. And I'm going to check my line cord. Okay, no continuity, not a surprise. We've been talking about inrush now for several videos, and we know that inrush is a problem with these tubes, or these radios. It usually takes one of the tubes out. We should probably check the switch just to verify that that's not the problem. And it is not the switch. As you can see, the switch is working just fine. So I'm going to connect back on the plug. And we'll take our schematic. Clean my board off here. And if we follow the AC in, now remember this is switched, this what set is switched on the B- line. We're going to be changing that. But if we come in as it exists now, we go through the 35Z5, the 35L6, yada 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 yada. So I have marked the heater pin locations on all the tubes so we can follow it down through there. Actually, this is probably shiny and screwing up the video. Let me get that out of there. That should be better, I hope. So I'm going to start with pin 2 to pin 7, and then from there it goes to the 35L6, and that would be pin 2 and 7 again. From there the 12SK7, it jumps to the 12SK7, pins 2 and 7, 12SA7, and that will be pins 2 and 7 again, and it's very often 2 and 7. It isn't cast in stone, but they're very often 2 and 7. 12SK, the next 12SK7, 2 and 7, and the 12SQ7, which is going to be 2 and 7 again. So we'll follow it through the radio. So our rectifier, our first tube in line is the 35Z5, which is this guy up here. Our line is coming in. Am I on the right leg? Yep, I'm on the right leg of the line, so we've got continuity to there. And that is pin 2, so 3, 4, 5, 6, 7. We have continuity there. That tube is intact. And then following the wire down, it should go down to the 35L6, which is the other end of the radio. And we should be able to pick that up on the 35L6 on pins 2 and 7. So there's pin 1, 2. Oh, nope, that's 1. There's 2. And 3, 4, 5, 6, 7. So we have continuity through that tube. So those two tubes in series are fine. The schematic says it goes to the 12SK7 next, which is this guy up here. Oh, actually, there's 2 of them. Probably goes to its neighbor. 12SK7. So, alright, so there. So it goes from pin 7 to pin 2 here. Yes, this 12SA7. Or K7, excuse me. And pins, I got 7 on the head. And that pin's good, so that tube is fine. From there, the wire runs up to and over to here, which is our other 12SK7, pins 2. Where are we? Pin 1, 2. And pin 7. Uh-oh. Uh-oh. There's our dead one. Pin 2, we have something. Pin 7, we have nothing. Oh, that's heartbreaking. Because very likely this tube had a lot of life left in it. You know, as they get weaker and weaker and weaker, of course, but the radios will operate fine until these are reading practically in the middle of the bad zone on a tube tester. Alright, let me go down and grab a 12SK7. Be right back. Okay, we have another 12SK7, and this one's got 100 written on it, which means at some point I've tested it, and it tests absolutely fine. I started testing and cataloging all my tubes once, and this was years ago, and the old 386 computer I had crashed, and I put so many hours into it that I just said, screw this. It breaks my heart to throw these away, because I know if the heater in it was good, the tube is probably fine, but it's gone. And let's see what we've got here. Yes, we have continuity through the plug now, so we now know our heater string is intact. So that's test 1 out of the way. The next thing I'm going to do is connect up the high voltage supply, and we're going to do the capacitor test just to see what kind of shape the electrolytics are in for testing purposes only. And I know I should be shotgunning them. I'm going to test the caps and see if I can bring this up without throwing money at it until I know that, you know, most of it's in good shape. So we're going to want to go from our B- line, which I know is here on the switch, and I can tell this is the across the AC line cap, and this is the cap that goes to ground. We'll get into that in a minute. And on the plus side up here off the rectifier of the capacitor, and it goes through this 2.2K resistor to the other filter cap. So let's see what happens. Let me get set up. Alright, our box is set up, our DC supply is on, I'm in the discharge, so these are not energized at this moment. And once again, we're going to go from the B- line here to the pin 8 of the rectifier, which is the first electrolytic 2.2K resistor, the second electrolytic. And, well, before I do that, just to cover the bases here, sorry, I gotta move the camera to get the drawer open. I'm gonna demonstrate what we're expecting or hoping to see. So this goes on the negative. Here's our two sections of the electrolytic. I'm just gonna tie them together. And I'm going to put my probe on the positive, and when I flip this to test, we should see this flash and go out. There, the capacitor's charged. And we're drawing no current on the meter over here. The light is completely out. In fact, I could pull that lens off and you can see the lamp's completely out. Now I'm going to flip this to the discharge, and you see that flash. The capacitor was holding a charge, so this capacitor would be fine to run the radio for testing. Now I'm going to check it in this circuit and see what we've got. And right there. Okay, I'm going to flip this to test. And right away I can see we've got a problem. One, it's drawing current continuously, about 15 milliamperes, and you probably can't see it, but the lamp is glowing slightly. But it's drawing current, so that tells me we have a problem, and that filter capacitor is probably leaking. So I am going to discharge it, and there's a second indicator that it's no good, because when I go for like just a second and then discharge, there's no flash, so the capacitor is not holding a charge. So we're going to be forced to change that one out before we go anywhere, because obviously it's leaking or something is pulling it down. What we can do to make sure it's the electrolytic, I am going to pull this connection right here, and we can test the electrolytics by themselves and make sure it isn't something else in the circuit causing the problem. So let me get this lead unsoldered. Okay, the common negative on the capacitor is disconnected. I'm going to put a test probe there, and this will just test only that capacitor. And are we in frame? Yes. Blink, and it's still drawing current. So if we turn this radio on, there's a good chance that could go short circuit, get much worse, and take our rectifier out. So before I go any farther, it showed a little bit of discharge that time, but let's give it 1001, 1002, nothing. That capacitor is leaking all its voltage away within less than a second. A good cap will hold it for anywhere from many minutes to hours. It's not dead shorted, but it's drawn about 15 milliamperes of current, which is absolutely no good. So I'm going to change that cap out. I'll be back. Alrighty. We have the electrolytic pulled out, and the schematic says 40 and 20, and this is at 50 and 30 microfarad. So I suppose it's possible this was changed, or they made a production run at some point. Oh, excuse me, I gotta sneeze. But we'll be fine, I'm sure, with 40 and 20 in there. We shouldn't pick up any hum. This across the line capacitor was going to be in the way of the ones I just installed, so I went ahead and pulled it out. And it is leaky, but surprisingly not too badly. That's a Solar. And Solar not only made capacitors, they made this capacitor tester right here. This pair of resistors, you can't see it probably. There's two of them there in parallel. It's supposed to be 2.2K. They have two 4Ks in parallel for 2K, but they've risen up. They're about 2.8K at this point. I'm not sure if I'm going to change them or not. It won't have any effect on the operation of the set. That's not enough of a difference. They look pretty manky, but they measure alright. I'll probably just leave those alone. But before we go any further here, the next thing we're going to look at is this coupling capacitor. Because remember, the 35L6 is running Class A amplification. It's single-ended, there's only one tube. If there was push-pull, it'd be a different story. But This is a single-ended amplifier, so it's going to be running Class A to be in the middle of its linear operating curve, which means with no signal on it whatsoever, it's going to be dissipating somewhere close to half of its rated output power in its linear curve. If this capacitor is leaking voltage, it's going to drive this grid positive, and that tube's going to be operating up here somewhere, just wide open, or down below here, and it's really going to start dissipating some serious heat. So we're going to change that capacitor, and I'll show you very quickly. Here's the test for the caps that are in there, by the way, at the moment. I'll put it up on the test position. You see it blink and go out. It's drawing 0 current over there on the milliamp meter. I'll put it in the 0 position for a couple of seconds, and you can see it's holding a charge. Again, charge, neutral, and blink. So the capacitors are now holding a charge. There's no serious leakage in here anymore. But I'm going to put this back up on test so that this B plus line here is energized, which will take us up through this 470K resistor, which supplies the anode or plate of our first audio tube. This capacitor is supposed to block any of that voltage from getting to the grid, but even with another 470K resistor pulling the voltage down, we're going to see leakage there, which means it's driving the grid positive. So we'll hook up to our B minus. And is the VTVM in frame? Yeah, I guess it is. I'm going to go down to, that's pin 5, 1, 2, 3, 4, 5 right here. And we have 9.5, almost 10 volts, 9.5 volts on the grid, driving that tube positive. That is not good. So I'm going to change one more capacitor, and then I'm going to feel comfortable at this point to bring the thing up on the variac and see if it operates, just to make sure we have a viable set. So let me get this other capacitor changed out, which is C4 right here, which is a 0.01 microfarad. We'll put a good orange drop in there, and then we'll test the set. Okay, we have our orange drop in here, replacing that coupling capacitor. While I was down here, I checked these two 470K ohm resistors. They're fine. I checked this mica cap. It's fine. Once we've powered it up and made sure everything works, I'll go through and completely change the rest of the capacitors that are in here. I'm usually suspicious. I don't know how well it's going to show up. There's a black licorice looking capacitor in here that's molded. They usually aren't mica. They're usually a molded paper. So I'm going to disconnect that guy and give that a thorough check, because they can be bad. That's this 56 picofarad one right here on the oscillator coil. But for testing purposes only, we should be fine. And again, I do it this way so that the guys learning, just starting out in here, have some kind of a guide to follow and won't panic if the set doesn't work after just changing a couple of capacitors. It's a whole lot easier to go back and double check your work just on a couple of caps than it is to try to figure out after you've changed 12 of them and the set doesn't work. So we're going to go dim bulb. I still haven't changed the cord out yet. Amazon, their second shipment of grounded cords, so-called polarized cords, was not polarized. Go figure. And I don't know if I mentioned it or not. I went to the dollar store and bought a bunch of dollar extension cords, but they're green. And I don't think I'm going to use them. I think I'm going to check another dollar store, or maybe the Goodwill store. A lot of times they've got stuff like this in the pile. And try to find some that are either black or brown. Okay. I'll move my Boycott Beijing 2022 down here for now. We'll turn the variac all the way down. Turn that off. Turn this down. Power that guy up. So the variac's live. We're plugged into our dim bulb. The radio is turned on. And can you see the... Probably not. Yeah, I guess you can see it. It's in frame. The other voltmeter will come alive around 40 volts, give or take. Okay, we've got about 100 milliamperes at 30 volts. So far, so good. We're up at 40 volts. Our other meters come alive, so now I can watch the current down here. 120 milliamps. Still on our dim bulb, of course. I don't see any. Oh, I'm starting to see activity up. The dial light's starting to work out. Wake up. Oh, that's something you guys might find interesting. Looking at the schematic here, it looks like it comes off the anode through a 47 ohm resistor, through the pilot light, then the filament string. That's our B minus line. It looks like they're passing all of the B minus through the pilot light, but that's deceiving. Because, hope I have the sketch here, I made up, oh yes I do. I have a simplified version, there we go, the light adjusted, simplified version of that schematic. What's really going on is the 35Z5 has a tap on the heater, and it's not a center tap. It's offset tap. For between pins 2 and 3, when this is up to operating temperature, if there's a lamp in the circuit, there's about 5.5 volts dropped across this part of the heater, and you have a 6 volt lamp. The rest of the heater drops to 30 volts. If you disconnect the lamp, you'd see about 7 volts across pins 2 and 3. So what's really happening is the B minus is coming up through the 47 ohm resistor to that tap, and then through the rest of the filament string to the B minus. So they are passing the B minus through the filament string. Some of it, of course, is going to be leaking through the lamp and through the filament string, but it's not carrying the bulk of it. Otherwise, when you turn the volume up on the radio, the light would be blinking with the audio. So most of the current that's coming out of the anode, most of your B minus out of the anode is going to come down here to this tap on the heater and down through the rest of the string. This tap is not center tapped, it's offset, so there's only about 5.5 volts. It's a clever arrangement, and they must have had quite a deal with the tube manufacturers to do that. Some, not all, but some of your All-American 5s, the AC/DC sets, will actually use one of these lamps directly across the 120 volt line. Problem with those is they get so bloody hot that they tend to discolor and damage the dials on a lot of the radios. And it's even made worse, excuse me while I move the camera just a second, it's even made worse on a lot of instances because people will replace these with these, which produce even more heat and damage the old plastic dials. I suggest if you have a radio with this type of light in it, put a 1 microfarad paper or poly cap or whatever you've got in series with the lamp. Just a 1 microfarad capacitor in series with it. You don't want an electrolytic, of course, because this is AC. So just a non-polarized capacitor, 1 micro. All right, that memory card's full. That must mean I've been talking for at least an hour. And so we're going to try to wrap this up, and we'll continue this in the next episode. But again, 1 microfarad capacitor in series with these lamps will dim them down. They'll run cooler, and at that level they will outlive you. The life of a lamp goes up exponentially as you drop the voltage or the current in it down a little bit. So, anyway, that's how that works. Let's continue bringing the setup. I don't know if you can see the lamp is starting to wake up. And we're still at 100 milliamperes. There's 68 volts, 69, 130 milliamperes. I'm starting to hear some activity. And it's awake.
Our neighborhoods. Learn more at goodwill.org. Sponsored by the Ad Council. WGIR Manchester.
News Radio 610, an iHeart radio station. And now, Leo Laporte.
And that's only 90 volts. This thing's going to be a hot little radio.
Anyway, in terms of...
Yeah. That's a nice little receiver. Okay, folks, I'm going to wrap it up with that. We know it works. When you see this next time, the caps, the caps will be changed. And we'll go through. I've got some more drawings here. We're going to explain how the AVC works, how the audio gets to the first audio tube, how it's detected, so on and so forth, so you have a better understanding of how the innards work. Now, I've done this before, but I did it with a transistor radio. This time we're going to go through it with a tube set because you guys are working, you know, if you're watching this, I'm assuming you're working on these old sets to restore them. And a lot of guys out there, you're new to this. The more you build, the easier it's going to get. And over time, you're going to find just as you do it, and you become familiar with how everything operates. After a while, it's going to become second nature. That's it for now. I'm the radio mechanic. Hope somebody found this helpful. And we'll see you again on the next chapter. We'll go through, you know, the alignment and an explanation of how the different stages operate in the radio. Take care. See you soon. Bye-bye.